Hello class. Today we're going to look at examples on AC circuit. And the example reads: an AC circuit consists of a pure resistance of 10 ohms and is connected across an AC supply of 220 volts and 50 hertz. That is the frequency. Calculate the current. Number 2, the power consumed. Number 3, the equation for voltage and current. So how do we go about that? When you connect those parameters in series, or when a parameter is connected or components are connected in series, we know that current flowing in such a circuit is the same. So that is the first thing that we need to note. So what we shall do, first of all, we need to get that current, and the current is given by the voltage over resistance as given in the equation. And once you know that formula, of course, now you can take the value of voltage, which is 230, you divide by 10. If you divide by 10, you will get 23 amperes. That happens to be the current that will be flowing in that circuit. Then we go to Roman number 2, whereby you expected to get power. Remember, we have formulas of getting power, but among them, you can see the power represented by P is given by the voltage divided by the voltage multiplied by the current. If you multiply the two, you will get 230, which is the voltage, multiplied by 23, which is our current. It gives us 529. And remember, power is given in watts. So the value of power is 529 watts. We move to the third question, whereby we expected now to get the instantaneous. In fact, the question should have been find the instantaneous values of voltage and current. So if you find you are being asked to get the instantaneous values, or sometimes you can be asked to get the equation for voltage and current, so this is the procedure that you need to take. You need to know that the values that we always provided within an AC are root mean square values. So this value is root mean square value, and that is where I've written the root mean square value of voltage is 230 volts. So, and we know that the root mean square value is always given by the maximum value. That is where we are writing Vm. Vm is the maximum voltage in that particular cycle. You divide by root 2. Root 2 is a constant. So if you make Vm the subject of the formula, you cross multiply. So you will get it is root 2 multiplied by Vm. So the maximum voltage in that particular circuit, which in other cases we call amplitude, is given by root 2 Vm. So now if you substitute, remember we know root 2 is a constant, and the root mean square value was 230. If you use your calculator, multiply root 2 by 230, you will get 325.27 volts. That is the root mean, that is the maximum voltage in that particular circuit. So once you get this, we can also get the same way you get the maximum voltage is the same way you will get the maximum current. So maximum voltage was given by root 2 multiplied by the root mean square value of voltage. Remember, the current will also be given, the maximum current is also given by root 2 multiplied by the root mean square value of current. So if you substitute, remember earlier on we had gotten 23. This was the current. Current was given by V over R, which was 230 divided by 10. Remember, this was our root mean square value of voltage. You divide by the resistor, you will get 23 amperes. This 23 amperes is the root mean square value. Because the value has been obtained from the root mean square value of voltage, the current obtained is also the root mean square of current, IRMS. And that is why you can see here, our IRMS is 23. So if you multiply the two, you'll be able to get 32.53 amperes. We have also discussed in before that omega is actually the angular velocity, which is given by 2 pi f. That is the omega is given by, that is the speed, which is given by 2 pi multiplied by the frequency. So this is given by 2 pi. Remember our frequency is 50. So if you multiply this expression, you'll get 314.16 rads per second, because we have said omega represents the angular speed. So that is the speed you get. We now move to the equation for instantaneous voltage. In instantaneous voltage, we said an expression is given by V is equals to Vm sine omega t. That is a general expression of a sinusoidal waveform. A sinusoidal waveform means a sine wave. So you can now replace in this expression our Vm was obtained as that 325.27. So you replace it here. Omega has been obtained as 314.16. You replace it here. So this gives us the expression for sinusoidal or an instantaneous equation for voltage. If you move to the instantaneous equation for current, remember current I, small letter represents an AC parameter. So the instantaneous value will be given by Im sine omega t. Remember our Im, this is our Im. Our Im is given by 32.53 amperes. So you replace it here, you will get that 2.53 sine 314. So that is the end of it. You get the answer. And we are going to stop there for now. Thank you.